welcome to this presentation. So today I called the presentation Building Data Pipelines with Open Source, but I have actually a few things that I want to kind of achieve with this. So I have a little bit of a hidden agenda here as well, because, well, it's not that hidden if I'm going to say it aloud in the beginning of the talk, but, you know, the idea is I would like to talk about this open source tool to build data pipelines, obviously. But I also would like to encourage you to play around with things that you haven't tried before, haven't done before, and try to find projects that can help you with playing around with this kind of data. And also, it doesn't have to be data, it can be something else as well. And the other thing is that we as developers, we have a lot of, well, you can call it hidden powers, so we can actually solve problems that we encourage ourselves, and we can use our knowledge of how to code, how to build solutions, how to build things to solve those problems. So this is the part that I kind of called as a hidden agenda. So, you know, encourage you to solve your own problems in a fun, creative way, and also learn something along the way. So that was a short introduction to what's going to happen. Now, I would like to start with showing you the final product, or the product that we kind of would like to see or want to see. And that is where I ask, well, let's see how that works, because probably this mic is going to pick it up, so it's going to be fine. Hey, Google, what's the bike availability near my house right now?
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
Okay, thank you. So it worked. I hope you heard it. So the idea is you can create your own app that will be giving you some kind of historical data and trending and stuff like that. But it makes pretty much not much sense now, because I haven't explained you what actually is going to happen. It's just to show you the final thing, and now we press on rewind button and we can talk about what the actual heck is going to happen. So the bikes we're talking about are these ones. So I don't know if you have those in Chicago, but in many places you have this city bike service where you have racks of placed all around the city. You pick a bike, you bike, and then whenever you want to leave it, you put it into the similar kind of rack, and then it gets locked. It gets locked, and then, well, you've used it, you moved from point A to B, and then, you know, you're happy, and then you pay very small amounts, like monthly fee or whatever, for those. It's been, a lot of that business was been taken by those electric scooters and stuff like that, but those bikes are still well alive and kicking nowadays. So what you see on the right side here is the bicycles that are in a city where I live, in Oslo, in Norway. And on the left side, the red ones, is from Belgium. And I've seen those everywhere. I've seen those many different places. I've seen this in San Francisco. I've seen them in Madrid. You name it. Everywhere something is similar. I guess, I don't know, do you have something like that in Chicago as well? Yeah. So that's the idea. The problem is the availability, because, well, we'll talk more about that. Let's talk about the good parts of it first. So the way they're kind of advertising it, this is like a picture from Oslo in the middle of the summer. I earlier, just before we started, asked some of you how it is in Chicago, and somebody said, well, it's really nice when it's summer. And, well, it's a very similar story in Oslo as well. It's very nice, as you can see in this picture. It's very nice when it's summer. It's like, you know, green grass and trees and water and, you know, small lakes and rivers. And this is the selling point of this bicycle service. Like, oh, you know, you can bike along the park, and it's really nice. There is another picture. I asked them, I was like, can you give me some marketing pictures, because I'm going to use that for a presentation. They were like, yeah, sure, this is really nice. So I got those pictures. That's another picture of a place in Oslo as well, quite central. Again, you know, very nice, very beautiful nature and everything. But again, this is summer. So biking in Oslo can be a little bit challenging, I guess, very similar to what you might see here in Chicago as well, in some, not so sunny days, let's call it that. But the idea is you can use your own bicycle or you can use this kind of service to do that. So let's go back to the nice and pretty pictures. And this one, it says spring, tra-la-la, spring. That's what it says on the sign there. And this is basically the advertising for that spring is here, that period is over, spring is here. You can actually rent a bicycle and do your stuff. The problem starts, so this is a picture of expectation. This is what you're being fed by advertisements and glamorous pictures. The problem starts when you actually hit the reality. By the time you need to get a bicycle, you're like, okay, cool, I bought the membership. I have this little card thingy or app or whatever that is you're using to lock it up with your bicycles. And I need to go from point A to point B. I don't want to take my own bicycle. I want to rent this thing or want to use that thing. So this is a picture you've seen earlier. This is a picture of a rack full of bicycles, and everything is peachy and nice and fantastic. It's a place very close to my work, so that's where I work. So I pass this thing every day. Sometimes it looks like that. Most of the time it looks like that. So it's exactly the same rack, but no bicycles. So that kind of sucks. The other problem is when you find a bike and you go to another place, all of a sudden another rack where you want to park your bicycle might look like a picture you see on the right side where you do not have an empty lock to actually put it. So now you have to bike around and find another one that has a spot available. So you have two problems. You can't find bicycles or you can't find available locks to put it in. And then, this is more pictures of the same place with empty bicycle racks. And then you get a little bit sad because, you paid for this thing. You kind of expected it to be there for a year or for a season, from spring to autumn. And, well, there is no bicycles, right? And then you might think, what has this to do with data pipelines? Well, it has a lot to do because this is the part where what I said in the beginning. When you have a problem and you know how to do some programming, how to do coding and things like that, you actually go like, look, I do this programming, I do development, system development and stuff for a living. So, and I have this problem, I might as well be able to solve it with my knowledge. And to give you a little bit of background information, so this particular bicycle service, it has an API. API is not giving you any historical data. It will give you only now time information about all the available racks in the city and if there is empty locks or if there are bikes available. That's all you get. And this is just right now. So you send a call, you get back all the stations with all the availability, and then you need to kind of figure out which station is where and everything, but you do not get historical data. They do have it, they don't share it. But the public API is just that. So then you start kind of, okay, I'll try to solve this problem on my own because, I paid money and I want to make it fun as well, and I might want to learn something in addition to that. So you start the plan and then you do, okay, what can we do? Well, we have a problem. We don't have any bicycles. That sucks. What can we do about that? Well, where can I actually find a bicycle? Well, like I said, I don't know because, I can ask availability of a specific stations and that's all I know right now. But the problem is, let's say there is this rack which is, 5 minutes walk from my place where I live. It takes me 5 minutes to get out of the door to that place. By the time passes of those 5 minutes, that last bicycle that was there 5 minutes ago probably will not be there because there is more people doing that. So, well, we don't know how to get bicycles. That sucks, again. Can I use the app? Well, they do have an app. but the app is using the same API, public API, showing you really pretty pictures on the map with pretty numbers, but I still can't get there. By the time I get there, it's gone because 10 other people saw that one bicycle next to them. That sucks. All right, what can we do about that? Okay, can we use public API? Well, like I said, same story, right? We can, but not really. Then you start thinking, okay, well, if I can't get a public API of historical data, if I can't know how it's going to happen, then I might as well start collecting that data and build the historical data myself and do all this fun thing. And then you can actually build your own big data in a very, very, very kind of liberate way of big part. But okay, I can do that. I can collect data, I can put it in a data warehouse and what to do that. And I mean, I work as an IT person, I do a lot of development, I do a lot of enterprise things, enterprise customers, and then you start thinking, how do I do that? I don't want like a super computer with huge data warehouse and cubes and all that. And what do I do with this thing? Well, I don't know, because I don't have the budget of a big company that builds all that, and I need to process a lot of data. I need to store it, and I want to make it as low impact as possible. So what I started with originally, I'll get back into that part quite in a bit, but what I started doing was collecting and dumping data on a tiny little Raspberry Pi on my desk at home. But then there was a problem. You would dump the data and you would store data, and then you wouldn't know what to do with it because it was just a bunch of JSON files. And also, since you've been using it a lot, the disk and storing and all that, my Raspberry Pi, the memory card on that crashed and died, and then I lost all the data, and that was kind of sucky. I could always write a Python script or JavaScript, or not JavaScript, but JavaScript, so a Java app. That can parse these things and do it custom, but I don't want to do that because it's going to be painful. I'll need to maintain all that, and it's not going to be as pretty as you think it is because it will be one thread, all that. I don't want to do that. Okay, so I want to have something that I can move around. I can run locally, I can run in the cloud if I want to, and all those things. I want it to be open source because one thing, it's going to be most likely free. The other thing, I get a lot of community around it, and so on and so on. All the benefits of open source. Oh, well, I can do that. That would be nice. And then you have like the last step, like, okay, if I do all that, I get some kind of profit. I mean, not obviously in money, but, I'll get bikes. Cool. So that was my thought process. And now, a few words about myself. So my name is Rustam. Like I said, I live and work in Oslo, Norway. I am working for a consultancy company. This is what I do during the daytime. It's called Compitas, all kind of Java stuff, cloud stuff, and architecture and all that. I am a Google developer expert for cloud, and I'm also one of Java champions as well. So I talk a lot about Java and cloud and all that. So I decided, now I want to learn about Java and data pipelines. And then I ended up with this pet project of mine. So the original idea, like I said, was a Raspberry Pi with all this data running locally. And I was like, okay, what can I do with that? Okay, I have some cron job. So every so many minutes, it will wake up, it will dump the data and store it in a file. So what I did was collect that data 4 times an hour, 24 hours a day for 4 years. So it's been running through whole pandemics, a couple of years before that, and it's still running. So 4 times an hour, I have a cron job that wakes up, dumps the JSON, and stores it just on a bucket, well, call it a disk for now. But what can I do with that? Well, because it's a batch processing, right, since I'm storing files. And I can, obviously, I can use Apache Spark or something like that to process all that, and I can put it into some kind of data warehouse that I installed somewhere, and I can use some kind of analytics to visualize it, Jupyter Notebooks or something else, and I'll get some graphs and pretty pictures and colors and stuff. Another thought was, okay, they're doing batch files now, but what if we can do it streams as well? I wanted to support streams, so like could be weather data, could be something else. I wanted to be able to support some kind of streaming as well. And then it was exactly the same idea, right? We do streams. Data comes through some kind of pub sub, like messaging queue, whatever. And then it can go into, again, Apache Storm, for instance. And you put it into data warehouse, into dashboard, and then it kind of visualizes together with everything else. I did not want to create two different pipelines. I wanted to have one code base for all that. And then, I was trying to redesign it. I was trying not to make it too enterprisey, but still quite enterprisey, because if I make it too enterprisey, I will have a server rack at home. I mean, it's really cool. That's my biggest dream, probably. No, but anyway, well, don't tell anyone. But one of my biggest dreams, it's really nice to have a server rack at home, right? Big pizza box with lots of colors and everything. But those are expensive. They make a lot of heat and a lot of noise. So maybe not very popular at home. So trying to keep it as less enterprising in this way, but still with all the features. So what can I do? So that's where I realized there was this open source project called Apache Beam that would help me with all that. So what is Apache Beam? Apache Beam is something, as you can understand, I mean, I've been building up this a bit of, I want to do this, I want to do that, and you can see this was basically the spec of this of Apache Beam, where you can do both batch processing and stream processing. We'll talk a bit more about what is what in a second. It actually has 3 different SDKs. Java SDK, which was the original one, then came along Python one, and then they also created Go SDK as well. So you can pretty much pick and choose language you want. And the other cool thing is that you create those models, transformation models and everything. So think of it as the ETL jobs, as if you've used those before. And then you can use it, you can run the same models, some same ways of transforming data on different platforms. You can read from different things. You can one day read from a disk, another day you can read from a bucket on a cloud, another you can do something, I don't know, go with some kind of advanced file system storage kind of thing. So it doesn't matter, Hadoop or something. And also you can run the same models, both locally, you can run them in cloud, you can parallelize them and so on and so on, so, which was really, really nice. It was originally started by Google, then they gave it away to Apache Foundation. They are open sourcing it, they have open sourced it, and they and now it's for everyone to use, right? So if you've seen the abstract of this talk, I talked a bit about swapping components, and what do I actually mean by that? So swapping components, like what I said earlier. So if you want to use one thing for storing stuff, you're okay, you can use that. If you want to use another thing for storing or reading data, you can do another thing as well. So on the right side, you have examples of storage. So you have S3 buckets, you have Google Cloud buckets, and then you have Hadoop and stuff. On the other hand, you have things for streaming. So up there, the blue hexagon is PubSub. So GCP, Google Cloud Platform stuff for PubSub, but it's also down there you have Kafka as well. So if you recognize the logos. So you can switch all those components and it's still going to work because you just switch different connectors, but the pipeline, the idea, if the files are the same, it will actually work, which is nice. So now we have a bit revised version of the architecture, because I work a lot with architecture. I'm a bit fan of boxes and arrows and stuff like that. I try not to do only that. I write some code as well, but boxes and arrows, that's your occupational hazard, I guess. So now we have ability to process batch files. We have ability to process streaming files or streams, and then we can put all that into a Apache Beam model to process. Then you can store it in some kind of data warehouse, whichever you want, and then you can visualize and do some magic stuff with it. This is an open source version. As you can see, I'm saying, like, for example, cron job up there, and then I'm saying a file system and stream and all this kind of things. Like I said earlier, you don't really want to have all that fancy stuff running on-prem, on your own machine, because, you know, electricity bill and, you know, reliability and all those things that you can do that. This is working, this is fine, you can use that. But then I also wanted to migrate and see how much it will cost me to move it to the cloud instead. So I created exactly the same version of that with the cloud. So this one is using Google Clouds, but you do not need to have only that. You can do it on any other cloud provider. Some of them natively will support Apache Beam. Some of them you will need to create some kind of virtual machines and stuff, but technically this can be done on any clouds with very small modifications. But here you actually see the products and things that I was planning to use. You have Cloud Function to create some kind of time job that will wake up, so serverless function that will just wake up, pull the data, store it into a bucket. So cloud storage, that's the buckets we have. It will do cloud data flow. That's a managed version of Apache Beam. So exactly the same thing, just running on the cloud. And then it will put into the output into a data warehouse, which I used in this case, BigQuery, because, you know, it was really, really fast and quite cheap. I have millions and millions of rows in there, and I still don't pay anything for it. And then you can do data lab or something like that to do visualization and things like that, right? So now we've talked a little bit about architecture. So now I want to go deeper into this box in the middle and actually explain how Apache Beam works. Any experience with Apache Beam? I asked that earlier, but I'll just ask again. No, okay, good. Then I will start with data pipeline. So what is a data pipeline? The data pipeline is, well, kind of what you see on the screen there. It's a pipe with things flowing through it. Well, the only difference is that with this thing, you pretty much know if you put something on top there, it will be pretty much the same thing going on the other hand. It's just kind of the redirecting the flow of water or whatever that is in that pipe. With data, it's a bit different. With data, it is it's still directional graph. It has one direction. It has no cycle, so it's acyclical. But you do changes to data. So you go from one kind of data, you do some magic with it, and at the end comes out something else. So think of it as a conveyor belt for, I don't know, a car manufacturer. You have a bunch of screws and small little pieces on one end. There is a conveyor belt going through the whole factory, lots of people doing some stuff, machines doing some stuff, robots doing some stuff, you know, all the magic happens. And then on the other side, you actually have a brand new shiny car. So kind of the data pipelines is like that as well. You have lots of bytes and bits of data, and on the other hand, you get something that you're useful for you. So going from, you see the difference? So this was like the enterprise piping. We go from very fancy pipes, we go to very simple pipe. So that actually is not a giraffe, it's actually a pipe. It's a lot of thought went into creating those slides. Or procrastination, I'm not sure which one. The thing is, how do you actually create a simple pipeline? Just, you know, to explain how it works. To do that, we need to see a little bit of the data. So this is the input. This is the data I'm getting from the API for this bicycle availability thing. So I get, what do I have there? I have an ID, which says me nothing. I have no idea where it is, but, well, I have an ID, cool. I have some kind of information about availability. So I know that, for example, station 177 has 4 bikes available and 24 locks available. So if I put those things together, I know that it has 28 spots in total. And then it has some other things like overflow capacity and stuff, blah, blah, blah. It doesn't really matter. It's not important. But think of it as extra properties. So what you get out is you want to go from this JSON into some kind of simple table like this. But as you can see, there is no timestamp on this thing. The timestamp will be, it's really, really, really weird way of sending data over, but that's how they do it. So they have really long list, and all the way at the bottom, there will be one timestamp for all that data. And obviously, if you want to put it into a table that you'll use it for analytics, you want to have a timestamp right next to each entry so you can actually know what it is, when that happened, and what that is. So the first task would be to create something from this into this. So then you create a pipeline where you can, this is funny. On my screen, those are, the square boxes are blue. On this one, they're all white. That's interesting. Okay, well, that's the magic of presentation, I guess. But it's not really important. The thing is that you have all those that have weird shapes are white, and the other ones are light blue. So imagine that they are. You have input files. You have a bunch of files that you've been dumping. You read those files. So the blue, the square box is the action. So you do read them. You do convert line by line into something. Then you put those things, you define pardoes. Pardoes is a short for parallel do. So it's something that can be processed in parallel without interfering with all the other things. And then you store it, you do some kind of transformations to it, you store it to a data warehouse, and you have at the end a data table, database table. So you start with a file, simple .txt, .json, whatever, you end up with a table. How do you do that? Well, first you need to define a bunch of options, which is a really cool thing. It's kind of verbose, but you really get used to that and you get really happy about it because pipeline options can define a lot of default values, so you don't have to supply them again. You say, well, if we're going to use file system, this is the path for the file system default, if I don't specify anything else from the command line. If we're going to do cloud, this is a path to a bucket default, if I don't specify anything else. And this is how I want it to be called, and all these kind of things. So you do not need to specify all that data that doesn't change over and over and over and over and over again. So in this case, we have a description that will be used and visible. You have default string, for example, for this method, which is getting input data for metadata about a station. So metadata about the station, we'll see about what it is. It is the information that we haven't seen on the screen yet, but it doesn't matter. It's just information about the station, like a name, geographical coordinates, and all those things that we haven't seen yet. So now that you have your pipeline options, you can actually create a pipeline, and this is all you need to do. You create a, pipeline create, and you push the options pointer to it. That's it. Not really exciting at all. The exciting part starts here, and this is where you actually take your pipeline and you do .apply and change things all the time. So every time you do .apply, you can add some kind of transformation. And like I said, you're not allowed to go, there is no circles, there is no cycles, so you cannot just loop back to the, to the previous transformation and say, do that again. If you want to do that, you will have to call it. So it's sequential in a way. So here is very easy. You just create a read. So text IO, I know I'm going to be working with text files. I do text.io.read. I put the options, from the options, the value for where to read it from. I create this new object that will do some transformations and stuff like that. I do some format transformations. So I have created a method format anything as text function. It just creates a text and removes all the things I don't need. And then it writes data. So in this case, I'm actually using text files. So I read from a text file and I write to a text file, just for a simple example here. Now I want to talk a bit more about this pardo thing. That's the thing in the middle. It's kind of funny. The background, it's not picking up this projector. It's not picking up the blue ones, but you can actually see the red circle. That's a good thing, I guess. But it's a very magic, black magic. Let's talk about pardo. So like I said, it stands for parallel do. It is a function that can be run independently from all the other things on many machines, many processors, many threads. No matter how many, it will still run and will not interfere with all the other things. So in my case, where I have been dumping 4 files, actually 8 files, because I would create 2 files per each call. But let's say for now 4 files, right? Because I'm doing 1 hour, 4 calls during 1 hour. So 4 files times 24 times 365 for 1 year, and I've been doing it for like 4 or 5 years. So you can imagine how many files you have. And to read all those files, if you will read one by one, it will take you a million of years. I tried actually running it on my machine. My machine started sounding like a airplane, very full airplane that was about to take off. Nothing happened for 2 hours, and then I had to stop. It wasn't able to. It was too much. But if you run it on a proper hardware with parallelization, all that, you can actually get a lot of things out of it. We'll talk about that later. But the point is, you have to create small pieces that can be parallelized. So when you do parallelize code, so pardos, you can actually do element-wise transformations. So you take something and you convert it to something else. So for example, here I do have created my own class, which is called station data, which extends from some kind of Apache Beam class that has a bunch of functions. And then I create my own override function that's called expand to do some kind of transformations and to do all my changes to this ugly JSON file that I read into a table formatted thing. So I can rearrange things, add values, remove some values, and so on, so on, so on. So now that I've created a pipeline, I've created options, I need to run it. And running that, you can do it. So this is an example. This is, like I said, this is Java versions. This is Java SDK. You could do it on the other SDKs as well. But here we're using Maven, and we are using, you're specifying quite a few things here. So you're saying, well, okay, we're going to execute Java. I'm going to use direct runner. Direct runners means I'm going to run it on my machine, local machine. I create a pointer to a main class. I provide some kind of arguments. So you remember I said pipeline options. So here I'm kind of overriding one of the pipeline options to say where the input files are. And that's pretty much it. So now, the cool thing with Apache Beam is that with all the code I created, with all the code I've written, and I run locally to test and make sure it works, I can actually go and move that thing into a cloud. And I do not need to change anything with the code. All I need to do is I'm going to switch back and forth those 2 slides, this one and the next one, so you can actually see the difference. So this is my machine. This is Google Cloud. So you can see that there's a few things that are changing. So first thing that changes from direct runner, it changes to Dataflow runner. So Dataflow is the managed version of Apache Beam running on the cloud. They're managing it for me. I don't have to think about it. I just provide them a model, they run it. And then you still have a main class, you still have some kind of arguments, but here you need to add a bit more. So you create, you say which region your data should be processed in because of reasons. You don't want to process your data somewhere else, and GDPR and all those things sometimes. You also tell where the bucket's going to be, where the input buckets are, where the output buckets are. So a little bit of housekeeping, but apart from that, it's pretty much the same thing. You just changed a little bit from this to this, and it actually runs. You don't have to think about it. And also you get a very pretty visualization of all that, looking like this. So this is an example of early runs of Dataflow on cloud, where I would just create that. And here on the side, you can actually see amount of machines it spin up to process data, and then it would just kind of fall down when there was no more data to process. So here I got, I think, like 17-ish machines at the worst. And then it was, all the data was processed. So it was, you can see there's little steps there. So it would just do increased number of machines. Like, do you have enough data? Oh yeah, I still have a lot. Okay, I still have a lot, still have a lot. And then it reaches like around 17 machines. Like, okay, cool. I can do that for a few minutes, and then it drops. So now I had this. So now this is a actual proper screenshot of how data looked like. That's cool. Just need to keep track of my time. That was the first version, and that was just a little bit of 1 million rows, so still not big data. Now I wanted to do something else. So remember I mentioned this magical thing of metadata? So there was another API that would give me, one would give me availability, the one that you see on the left, you've seen that before. The one on the right is the metadata, so it contains like things like geographical coordinates. It creates, it contains a name, a description, where to find it, if it's in service, if it's kind of retired, and so on, so on, so on. Now I want to do this. So I want to join those two data sets together. And that's kind of fun, because now we're doing a bit more advanced things. We just had a very simple pipeline where we just take something, process it, create something else. Now I want to take two things, process them together, and create something else. And there was much more files. So by that time, I had around, what was that? 600 megs of files. And that was just like, I don't know, 6, 7, 8 months worth of data. So now I wanted to create something similar. I see, again, this projector is not showing you arrows and stuff, but there are arrows in between. So now we have two different starting points, one for files with metadata, one with files for availability. And at the group by here in the middle, let's see if I can get a pointer. Yeah, there. So here, I'm merging those two. So there is a line going in here, and there's another line going in here, and they all merge here, and it gets processed and everything. So now I would be able to process two different pipelines, join them together into one meaningful thing, and still store it into database. I had much more data now, and now we were at around 150 machines. So I think this is 150 here. So now there was much more machines to process all that. And we had much more data as well. So now we're all of a sudden into 13 million rows. So, you know, that's a little bit. It's around 5 gigs of data. I know I put it in my notes to know how much data it roughly I had to process here to create those 13 million rows. And, you know, I did that. And it was, this is actually a newer screenshot from when I added more data to it, because another year passed, I wanted to process more data and stuff like that. So this was from last year in July 2021. And then all of a sudden we were in 21 million rows, right? So it was quite a lot of data I needed to process. But then, 5 gigabytes of data, you saw that. It was like 150 machines for how many minutes? Roughly 10, 15, 20 minutes, I guess, here. So this is 150, and this is like the amount of time. So 150 machines for, let's say, 15 minutes. How much did it cost? Do you have any idea? Because what the thing was, I started running that. I got a warning, because it didn't tell me what it is until many hours later, but I got this. So that was my billing account. I removed the amount of euros for now, just to tell you, to keep you a bit in the suspense. But the thing was, it was like almost 900% increase in billing. So now to make it a bit less exciting, it was that I had pretty much no billing at all. So 900% of nothing was kind of nothing still. Any guesses how much it cost me to process 5 gigs of data? For 15 minutes, 150 machines? Give me a number. In euros, well, pretty much the same as dollars, so give me dollars. $2,000. Okay, $2,000 going once. $2,000 going twice. I'm not that rich, I'm just saying. $2,000 going, anyone? $40, okay. $40 going once. $40. Okay, well, I'll stop. Yeah, so that's what it costed me, really. And that is the funny part, because you can see in the billing here, I got a huge spike to whole 3.5 euros, so $3.5, and it just went down. And that is really, really amazing thing with the cloud. So you can actually process a lot of data, big amounts of data, without needing to actually going bankrupt. I mean, I would be very concerned if it was $2,000. I would be a bit less concerned if it was $40. But you know, when it was like $4, I was like, okay, I can do that. I can pay for that. And that's kind of the surprised monkey picture comes in, because we had the sad puppy instead in the beginning. Now we have the surprised monkey. So that is Apache Beam. So you can run it locally. It works really fine to test and everything. But if you need to process big numbers of big amounts of data, it's much better to do it somewhere else that can actually let you parallelize it, and it still doesn't cost you. But like I said, I'm not advertising for any specific clouds. You can do it in other clouds. This is the one I used, so this is kind of opinionated version of this talk. But you know, you don't have to. And this is what we implemented so far, right? So we have batch processing, and then we put it into data warehouse, and then you can actually get something out of it. I also have a set of slides. How do we go from batch to streams? But I'm not going to talk too much about it, because we don't have much time. We're starting a bit late. So the point is that with batch, you have a set of files for, let's say, 1 day, 1 hour, 1 minute, whatever. With streams, it's just like, well, it's a stream. It's just it's continuous thing. And the problem is there that the data for, say, 8 o'clock in the morning may arrive at 8 o'clock in the morning. You see the timeline there at the bottom? But it also may arrive a bit later. It can also arrive even more later. And you have to do something. You have to handle that. You cannot just say, well, you know what, at 8 o'clock, all the data came in, it was 8 o'clock, and we're cool. It actually can arrive much later. Apache Beam has a few cool things. It can do, well, transformations, we've seen that, but it also can do windowing, so you can actually have a sliding window to look at the data. You can also add watermarks and triggers. When the data comes in, you do different things. And also you can collect data, so you can accumulate data as well. And then you have different ways of processing that. You can do element-wise transformations, kind of what I showed you earlier, but you can also do aggregation, also kind of what I showed you earlier. When you create 2 different data sources, you put them together and do that. But you also can do a composite, like a different variations of all that. And then you can create things in different windows and store them and do all these magic things. All right. A few cool features before we call it a day. That is, one of them is how to create windows. So let's say you want to create a window looking at data for past 5 minutes, but if you move that window every minute, that's how you do it. That's all you need to do. You say events apply, duration of 5 minutes every 1 minute. It's kind of almost natural language, right? You can almost read it and understand what's happening. The other thing is that when you run things locally, you do not have a visualization of the pipeline, which kind of sucks. You need to upload it to a cloud just to get visualization, and that's not really fun. So I created a little blog post after digging into actually documentation and, well, lacking documentation partially, to create a very simple representation of the dot graphs. So you can actually create the graphs like this on top there with just a few lines of code. There is a description how to do that at the bottom there as well. So I put it on the blog post some time ago. And also the cool thing is that when you actually create pipelines, it's very easy to replace parts of it with another thing. So like, for example, storing to files. I didn't want to store to files. I wanted to store to a database. I could just redirect the pipe into something else, and it just works. And with code, it looks like, it used to be like this, right? You remember we had text.io.write. Well, you remove those 2 lines, you add a few more things to a database with connection and options and stuff like that, and all of a sudden you have you have this thing there. And when you do all of that, you can actually create very fancy statistics. You create very fancy queries. It took some time to create, but then you can create, like, where are the most broken bikes? Where are the most available bikes? Where it's never any available bikes, and so on, so on, so on. And this is the fun part again. One last word of warning is that you're still working with live data. So your data sources will change, your structures of the data you're getting might change, and you probably need to count on that, and it will break your pipelines. It happened to me because one day they just suddenly decided to return JSON pretty printed instead of not pretty printed. And then I all of a sudden had like everything breaking because, well, Apache Beam does not support line breaks because it processes line by line. That sucks. And well, I mean, they're doing it for a reason, and that's actually a very good reason for them doing that. But the API that giving me data, they're not doing things for a good reason. But that's another story. All those kind of things, people don't do proper API management. They change API without letting you know. They create new APIs without creating new versions, and so on and so on. So all that will break your stuff. So you need to be prepared to, jump in and fix it. But that's how it is. That's a bit of the ETL kind of fun part. And this is a quick recap of what we actually have built or we can build with Apache Beam. And if you want to play around with the code, it's right there. So the code and all the simple examples and everything is there. I mean, it's very subjective to say I like this example better than the standard examples that you get from Apache Beam, but it really didn't help me with the standard examples of word counting and stuff like that they have on their documentation. So I created my own fun little project to play around and create and play with data pipelines. We are out of time, so I will be outside and I will be happy to answer any questions. If you want to get hold of me, this is me on Twitter and also my email. So feel free to ping me if there is anything. One quick question, if we have, if we can do it very quick. If not, we do it outside. Anything? Okay, I'll thank you all now for now, and then we can continue outside there. Thank you all for coming.